Okay, now this is the second lecture about flow past immersed objects. And the previous lecture I talked about general concepts, where I answered questions about what's the meaning of drag, when do we want to reduce drag, when we do want to increase the drag, what are the main applications in chemical engineering of drag. So here I will talk about types of drag, which is the second point here. So the question to be asked, what are the two types of drag? What are the two types of drag? So let us look at the answer of this question. So the force exerted by the fluid on the solid in the direction of a flow is called skin or wall drag, where the surface is parallel to the direction of flow. So what do we have here? Suppose I have this is the object, okay, or this is the solid, which is this one here. As you can see, it can be a plate. This is the plate. And then I have a fluid which is flowing in this direction. This velocity V0 or V sub 0 is called the free stream velocity. Free stream velocity. So this is the velocity of the fluid, before contacting the solid. So this is the solid. Here, this velocity is not affecting by the solid yet, so we call it free stream velocity. And this is the first form of drag, where this object, as you can see, this object here is parallel to the flow direction. And in this case, we call this form of drag skin or wall drag. And what is special about it? It is when the surface is parallel to the direction of the flow. The surface here is parallel to the direction of flow, as you can see. This is the first type. Now, suppose the fluid is not flowing parallel to the surface, but changes directions to pass around the solid. So in this case, significant additional frictional losses will occur called form drag. So the first one that we talked about in the previous slide was the skin drag or wall drag. And the second one, when the fluid has to pass, as you can see, now the fluid has to change directions, okay, to change direction to pass around the object. And this is called form drag. Why? Because it depends on the form, on the shape of the object. And here again, as you can see, let me discuss different things. So I have the free stream velocity V0 again. I have a point called stagnation point, and we discussed this before. If you remember, we talked about the flow measurement devices, stagnation. And I have the boundary layer. Also the boundary layer, we talked about it before. What's the meaning of it? We talked about the pipes, the flow inside pipes. And I have another point which is called separation point. So what is the stagnation point? Again, this is the stagnation point. As you can see, the fluid is coming with a velocity, and at this point, it's like the velocity of the fluid is equal to zero. Stagnation means not moving, to stationary, okay? ثابت ما يتحرك. So stagnation point, it is the point where the fluid velocity is zero. And at this point, the boundary layer growth begins. So this is the boundary layer from here to there. And from this point, as you can see, this is the boundary layer. The boundary layer will start to grow. So the boundary layer growth begins at this point and continues over the surface till it separates. So from here, the boundary layer will grow, and then there is a point where the boundary layer will separate here, as you can see, and here, as you can see. Okay, so this is called stagnation point. This is the first thing. So we talked about the form drag in this slide, which is the second type of drag, and we talked about the stagnation point. The other thing is the streamlines. طبعا you know what is the meaning of streamlines. Streamlines, they will show the path of the fluid elements around the suspended body. So those are called, this is a streamline, this is a streamline. So all of those are streamlines. And then what is the separation point? So the separation points will take place at sufficiently high velocities. So as you can see, this is the boundary layer as we called it, but there is a point where the boundary layer will separate. I will have like two regions. So at sufficiently high velocities, the fluid stream detaches itself, okay, from the surface of the body. So at this point, I will have like the boundary layer. It's going to split. One of them will just continue to be close to the body, and the other one is going to form eddies or wakes, as you can see here. So this region is called the eddies or wakes, and it will continue after the object, and then after some distance from the object, so the effect will diminish, it will just disappear, and things hopefully will just continue as it is. So the separation point, the boundary layer will separate. The streamlines, they will show the direction of the flow. And the other one, which was the stagnation point, it is the point where the fluid here, the velocity equal to 0, and the boundary layer will start to develop. So again, here we are talking about the two types. So the tangential stress on the body because of the velocity gradients in the boundary layer is the skin friction or skin drag. So inside the boundary layer, then we'll have the let us say the skin or the skin drag, okay, or the wall drag. However, outside the boundary layer, then where the fluid changes direction, there will be another force affecting the body, which is the forward drag. So it's like then the skin friction is manifested here. يكون تأثيرها في المنطقة اللي هي الباوندري لاير داخل الباوندري لاير, and outside the boundary layer it is the forward drag that will affect, let us say, the object. Okay, these are the two forms, and where is their, let us say, where their effect is pronounced. Now you might ask, like, where this point of separation will happen, at which point of the shape of the body. So the point of separation depends on the shape of the particle, depends on the Reynolds number, okay? And we are using this notation here, NRE, because this is from another reference, and I just want to stick to the notation. So when you see this NRE, we are talking about Reynolds number. So here we are saying that the separation point, okay, let me go back to the slide. The separation point, which is here, for example, depends on many factors, but two main things are the shape, the shape of the particle, the shape of the object, and the Reynolds number. So also we have to worry about Reynolds number here. And the forward drag can be minimized by streamlining the body. So we said that usually we want to reduce the resistance of the body, for example, to drag. And we can do this by make it more aerodynamic. And by saying that the object is more aerodynamic, we make it more streamlined. And as you can see here, when we have done this to the object, it is not like a disc or a sphere anymore. We have done it this shape, and by doing this, we just forced the separation point towards the rear, okay, or towards the end. So now this is the separation point, which is just pushed towards the end, and here we have less form drag. Still, as you can see, this is the stagnation point, and here is, as you can see, where the boundary layer started to develop. Okay, all of this is the boundary layer, and here is the small thing where we will have the eddies and the wakes, and we will not have a lot of losses because of the form drag, which is different than the previous case. So let me go through this sentence again. So form drag can be minimized by streamlining the body, forcing the separation point towards the rear to reduce the wakes or eddies. Okay, so in those slides, this was a quick lecture. So in those slides, I talked about the two types of drag. I said the first one is called the wall or skin friction or wall or skin drag, and the second one is called the form drag. The form drag can be reduced by streamlining the body and forcing the separation points point toward the rear to reduce the wakes or eddies. And also we said that the separation depends on the shape of the particle, the Reynolds number, etc. So inshallah in the next lecture we'll talk about the drag coefficient and how to calculate it.